So this is just a quick video for the differential equation problems that are in your packet that you worked on. If you're in my class, we have the posted solutions, but now I'm just going to walk through and explain in case the posted solutions are not enough to support you. So in problem number 1, we have x squared plus 1 multiplied by the differential, or by dy dx, equal to 4. So remember when we solve differential equations, which is what we have here, the first thing we're going to do is to separate the variables with all of the y terms on one side and all of the x terms on the other side. So in doing that, you'll notice the first thing that I did was to divide both sides by x squared plus 1. Then to get the dx to the other side, I moved the dx to the right-hand side. So notice on the left-hand side, everything is in terms of y, and on the right side, everything is in terms of x. Also notice that I took the coefficient of 4 using integral properties and put it in front of my integral because that helps my math eyes to see what I need to see. Hopefully when you look at that integrand, you are noticing that it is the perfect form of inverse tangent, so there's really nothing that we need to do, no u substitution, no manipulation. So on the left-hand side, the antiderivative of 1, remember there is a 1 in between the integral symbol and the differential dy, so when you integrate 1 in terms of y, you get y. On the right-hand side, I keep my coefficient of 4. The antiderivative of 1 over x squared plus 1 is inverse tangent of x. Don't forget the c. Problem number 2. Again, we're going to separate the variables. This time we have an initial condition that is going to allow us to solve for c. So we're going to need the c, and then we're going to solve for c. So let's see how it goes. The first thing I'm going to do to isolate dy dx is to add 1 to both sides and then divide by divide by x. So I added 1 to both sides and got x squared plus 1. Now I'm going to divide by x and probably move the dx to, yep, that's what I did, move the dx to the right hand side. So my variables are now separated. So I have all my dy terms on the left side and all my x terms on the right side. To find the antiderivative of the left side, of course, that's just going to be y, but to find the antiderivative of the right side, I'm going to need to separate or break apart, we like to say, or Miss Oliver math. I'm going to divide x squared by x and get x, 1 by x, and keep that as 1 over x. On the left-hand side, the antiderivative of 1 dy is y. That's the left side. On the right side, reverse power rule, x squared over 2. The antiderivative of 1 over x is ln, absolute value of x. Don't forget the c. Remember that we had an initial condition where x is 1 and y is 0, so I substitute a 1 in place of x and a 1 in place of x and a 0 in place of y. Do the arithmetic. Remember that the ln of 1 is 0, so c is equal to negative 1/2. So I substitute that value in place of c, and I get x squared over 2 plus ln absolute value of x minus 1/2. Problem number 3. In problem number 3, I'm going to separate the variables because I have a differential equation. I'm going to divide both sides by that square root of. So that's my first step. And in my second step, I'm going to use integral properties to move the coefficient of 2 in front to clear my math eyes. All right, I'm going to cover that back up because right here under the square root, I have a negative x squared plus 4x. Now I could try u substitution and it will dead end. The square root hopefully is a little hint maybe, and the square on the x is a hint that maybe we might be looking at something inverse trig. So since u substitution will not work, I'm going to move to completing the square. Even though there is not a constant term, you can still complete the square. So we have negative x squared plus 4x. Remember when you complete the square, the coefficient of x squared needs to be a positive 1. So phase 1, I am factoring the negative out, and that leaves me with positive x squared and minus 4x. And then I made room for what I need to complete my square. To complete the square, I'm going to take the coefficient of x, ignoring the sign. In other words, I'm going to take the 4, divide by 2, and square that number. So 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add a 4 on the inside, but being very, very, very careful. I'm actually going to grab the pen here, because even though it looks like we're adding a 4, we have to remember that that 4 that we just added on the inside gets multiplied by a negative. So it seems like we're adding a 4, but it's actually a minus 4. And so to compensate for a minus 4 and make a 0, I need to add 4 on the outside. Those negatives are very dangerous. All right, now I'm going to factor that, and it becomes x minus, or the opposite of x minus 2 squared plus 4. I'm going to carry that back over to my problem and put that in. So now hopefully I'm clearly seeing an inverse sine situation. So that's going to be, my u squared is x minus 2 quantity squared. My u is x minus 2. A squared is 4. A is 2. So then I'm going to use my formula for inverse sine. Coefficient of 2, inverse sine, u, which is x minus 2, over 2. Don't forget the c. And lastly, problem number 4. I'm going to divide both sides by this fraction. And remember, when you divide by a fraction, it's multiplying by the reciprocal. So when I separate the variables, I get 5 over 3 plus 16x squared. The 5, I'm going to get that out of the way using my integral properties. So the coefficient is out of my way. And hopefully I am noticing inverse trig. I could try u substitution, but that certainly will dead end. So in this case, I'm going to my u squared is the term 16x squared. Therefore, u is the square root of that, which is 4x. Du, because we have a coefficient, is 4 dx, and I don't have a 4 in my original problem, so I'm going to need to compensate for that. My a squared is not a perfect square this time. My a squared is 3, therefore a is the square root of 3. All right, now that I realize it's inverse tangent, I have my coefficient of 5 in front, and remember it's 1 over a, so my a value, that should not be a 4, that should be a square root of 3. I'm just noticing that now, so let's fix that. I don't have my tablet. I wasn't planning to do any writing. All right, so give me a second here. Glad I caught that. So this should be 1 over a, which is the square root of 3. So 5 over the square root of 3, inverse tangent, and then it's u over a plus c. All right, good catch, Jernigan.